Okay, so we want to look at the situation where we have tangents and secants intersecting. And here we have three examples of intersection points outside of a circle. So we have all the different combinations. So we have a pair of tangents intersecting outside of the circle. We have a tangent intersecting with a secant outside of the circle. And we have two secants intersecting outside of the circle. No matter what is intersecting and which pair we have, the situation is always the same, that we have the far arc minus the middle arc. If we take that difference and divide it by 2, then we get this angle. And same with going over here. So see, this tangent question is actually a little bit of an extra step process. So let's take a look at this secant tangent question first. And here we can see that this arc DA, that's a measure of 165 degrees, while this measure CA is 55 degrees. Well, if I have this angle here, B, that opens up and intersects both of those arcs, then I know that 18x plus 1 is going to be equal to half of the difference of those two arcs. So it's going to be half of 165 minus 55. So again, you can see that this far arc minus this closer arc divided by 2, or half of it, is equal to the measure of the angle. So just solving this algebraically now, I have 18x plus 1 is equal to 1/2 of 110. That's the same as 18x plus 1 is equal to 55. If I subtract 1 from both sides, I get 18x is equal to 54. And if I divide both sides by 18, that should give me 3. So x is equal to 3, and that's a really nice problem. So if I look here, I know that Km is 34x minus 1, but I don't know what this major arc Km is. Well, don't forget that arcs add up to 360. So if this is 34x minus 1, this arc is 360 minus that 34x minus 1. So if we set this up, again, we know that that angle, 45, is going to be equal to 1/2 of the difference of the far arc. So that's going to be 360 minus 34x plus 1. And it's plus 1 because when we distribute this negative in, minus times minus is a positive. And we're going to subtract this 34x minus 1. So in doing so, we subtract, we get minus 34x. Again, we minus a minus, that's really plus 1. So now if I clean this up, I get 45 is equal to 1/2 of, combining the like terms, I have 360 plus 1 plus 1. So that's 362 minus 68x. These are both even, so I can actually distribute this in, and I can say that 45 is equal to half of 362, which is 181 minus 34x. If I add that 181 to both sides, I'm going to get 226 is equal to negative 34x. I'm sorry, that was a minus. I should have subtracted. So if I subtract 181, I'm going to get negative 136 is equal to negative 34x. Let me just double check that on my calculator. So again, I have 45 minus 181. Yes, that's negative 136. And then I can divide that by the negative 34. And I get that x is equal to 4. So this involved a lot of algebra, but the concept is still the same. If I have the difference of the far arc minus the close arc, and I take half of that and get this angle. And it still holds true for secants. So here I have two secants intersecting each other outside of the circle. So that means that, separate my problems here, this means that that angle, 37x minus 1, is going to equal 1/2 of the difference of the far arc, which is 121x minus 1, minus the close arc, which is 48. So here I have 37x minus 1 is equal to 1/2 of 121x minus 49. Now, unlike the problem over here with the two tangents in red, I was able to distribute in this 1/2 because they're both even. If I do that here, there's nothing wrong with it, but then I'll just get fractions or decimals, which can add some stress to the situation. So instead what I'm going to do is I'm going to multiply both sides by 2. And so over here, when I multiply by 2, I get 74x minus 2 is equal to 121x minus 49. If I combine my like terms, if I subtract 74 from both sides, I'm going to get 37x is equal to, if I add 49 to both sides, I'm going to get 47, and something tells me I added that incorrectly. Yes. Sorry, 121 minus 74 is 47. So I get 47x equals 47, or x equals 1. Yet again, the situation where this angle of the two intersecting secants is half of the difference between the far arc minus the close arc. Now what happens if they intersect on the circle? Here we have two situations where we have a tangent intersecting a secant. The situation for this is that this angle, formed by the two, is going to be half of the arc. So that means that 8x plus 3 is equal to 1/2 of 102. So 8x plus 3 is equal to 51. If I subtract 3 from both sides, I get 8x is equal to 48, or x is equal to 6. Think about, for a second, if you have a diameter and a tangent. These intersect at a 90-degree angle. Diameter cuts the circle in half, so this arc is 180. Notice how this 90-degree angle is half of 180 degrees. Same whenever we have this secant. This secant and the tangent are going to form an angle that's half of the intercepted arc. So if this arc is 102, this angle is 51. So for that next problem there, again, we have the same situation, where we know that that angle 45 is going to be 1/2 of 10x plus 10. Now again, two situations. These are both even numbers, so I can distribute this in and get 5x plus 5, or I can multiply both sides by 2. If I multiply both sides by 2, I get 90 equals 10x plus 10. Subtract 10 from both sides, so I get 80 is equal to, not 8, I get 80 is equal to 10x, divide by 10, and I get x is equal to 8. So these are, again, some nice problems. When the tangent and the secant intersect on the circle, the intercepted arc, the angle is going to be 1/2 of the intercepted arc. When the secant and the tangent, or the tangent and the tangent, or the secant and the secant intersect outside of the circle, the angle is going to be 1/2 of the difference of the arcs. So all of these are very nicely related. So again, as long as you understand the pattern, then you should have really no difficulty getting through these problems. Best of luck.